Should warn you. Recording has started, starting transcript. So, okay. Yep. Sawyer, take it away.
All right, excellent. My screen coming through.
Yes.
Cool. Yep. All right, so let's kick things off. And this, smaller group tonight, we're not going to take probably a full hour here. We might wrap up in 30 to 45 minutes. We'll see how much discussion we have, I guess, or how interesting this topic is for y'all. But tonight is the flavors of Spark, thinking about leveraging the scalable compute engine and how does it fit into data architectures, big data architectures. There's my contact info, my LinkedIn, and love to make friends, reach out there, happy to connect. Here is just a bit more about me. We've already covered a little bit of this, but I'm based in Grand Rapids area. I think Michigan is a state with the best summers, so I love living in Michigan. It also has, the longest winters, it feels like, but love Michigan summers. Been a data platform consultant at some gold partners and then at Microsoft now for 2.5 years. And then I run a boutique consulting company called The Data Shop. And the Data Shop, I particularly am interested in serving nonprofits and not-for-profit organizations. So community organizations, charitable organizations, ministries, credit unions, things in that world. So kind of, I'm particularly designed and interested in working with solving data problems and hopefully making their data into more of an asset and a value to them instead of just a liability. And I write a short daily newsletter called The Data Daily. If you're interested, there's a short URL you can jump on board. It's really a short email about helping data people with business and helping business people with data. And that nice little Venn diagram of intersecting those two worlds is a fun circle to explore. So that's a bit about me, and that's probably all about me. The rest of the slides are much more technical and exciting. So here we go. The Spark is the de facto kind of data runtime in the data engineering world, data landscape now. And there's lots of different flavors and lots of different ways that Spark shows up, surfaces in different products, and it also fits into data architecture in different ways. And so we're going to try to break down what those flavors are that's available. What are the use cases? What do you do with Spark? And then maybe some tools for picking the right Spark option. And so here we go. Here's the roadmap. What is Spark? What do you do with Spark? How does Spark fit into data architectures? What are the 4 flavors, 4, 5, 6 flavors? There's a couple of them that kind of merge together, flavors of Spark. And how do you pick a Spark flavor maybe? And so this is kind of a 201 level presentation. If you are newer to Spark, then you probably will learn some things and hopefully will flow right in. If you're already a Spark expert, then we'll have some time at the end, you can correct me and debate about anything that I said wrong. But let's dive in. Thinking about what is Spark at a foundational level. Everybody just talks about Spark out there, but like what is it at its core? So of course, we're going to start with a Google search. If you Google Spark, you're going to land on spark.apache.org. It is an open source project hosted, managed by Apache. And it's the natural successor to MapReduce. So if you've been in the data game for a decade or more, then MapReduce, you're probably familiar with MapReduce, or you had to work with MapReduce. And it's a natural successor to MapReduce. Specifically in this way, Spark is an in-memory data processing engine, which is much faster than the disk-based processing of MapReduce, which makes it a dramatic improvement over MapReduce, as well as a lot of the complexities of MapReduce and the overhead, goes away, and Spark has a lot more scalable ways and easier ways of managing those pieces. But I specifically want to hone in on the definition of Spark as a way of taking apart what do you do with Spark. So Apache Spark is a multi-language engine for executing data engineering, data science, and machine learning on single node machines or clusters. And so we're going to use that. We're going to take that apart for a second and talk about 3 things that you do with Spark. So first off, it's a multi-language engine for executing data engineering and data science. So Spark is compute. It's a compute engine, a compute processing engine that runs on clusters. Well, we'll get to the cluster part in a minute, but it's particularly good with reading and writing with files. Spark's great at working with files and events in a data lake, which is something that a lot of traditional RDBMSs didn't do well and don't do well. You're not reading from the data lake with SQL Server very often. That's not a common path. It's not something it's really designed for. It's designed to read in-memory tables, which is makes Spark a separate and distinct tool set. It's designed for working with files. And it's designed to do data engineering tasks. So streaming data, batch processing, code-based data pipelines. That's a core part of what Spark is. It's an engine for data engineering. A second thing that's key to Spark is it's a multi-language engine for data science and machine learning. So you'll see some of the big use cases for Spark are around the multi-language capabilities, being able to use not just SQL, but R, Python, Scala, Java, providing lots more flexibility for those more advanced use cases, data science and machine learning, the advanced analytics, AI, ML type workloads. So Spark's great for that. That's another second key use case of what do you do with Spark. The third thing to think about Spark is that it runs on a single node or clusters of machines. So it's designed to be a scalable architecture, parallel distributed computing. So highly scalable compute, fully separate from storage. Spark doesn't have any disk storage. It's in memory only. And so it's a compute engine that runs on singles or clusters of machines. And that lets it be distributed and scalable in lots of ways. And so here's just a diagram of kind of how Spark operates. And if you can see my mouse, we'll kind of think about the head node being, the main driver of the program. It's the manager of everything that's happening. And then on the bottom, we have HDFS or a Hadoop file system, any Hadoop file system compatible. So that could be AWS S3 buckets. That could be ADLS Gen 2 buckets or containers. And so we have our data down here. We have a cluster manager up here that helps to distribute the workload and the task to a variety of worker nodes. It could be one node, it could be many nodes. This is the beauty of Spark, is you can scale it appropriately. And the cluster manager assigns tasks to a worker node. The worker node reads the data into cache, performs the task, returns the results to the cluster manager, which then returns it to the user. And then it continues on and processes the next task. And it can get scaled across as many nodes as is practical or necessary. And it's also really simple because you can also just download Spark directly onto your machine and run it locally with the small nodes that you have on your local laptop or desktop. So it's a beautiful architecture with small to large and scalable. And there's two different patterns and two kind of frameworks that I want to think about. So we know what Spark is. You can do data engineering, you can do AI, ML. It can scale from a single node to many clusters of nodes. And how does that fit into data architecture patterns? What are the ways it really fits, and how do we leverage it? And there's two key frameworks that are relatively new to the scene that are really becoming pretty foundational to the way we think about data architecture. And so step one is the separation of compute from storage. So over the last few years, the data world has made a key shift towards separating these two things. Traditionally, your compute and storage have been tightly connected in SQL databases, right? Your data lives where your compute lives and vice versa. And your database comes with X number of storage for X number of nodes. And in these two, generally, those two things scale together, up or down. And when you hit a bottleneck in one of these two, like you're forced to scale both, it can sometimes be overall increased cost. And so one of the key advantages here is the ability to scale your compute separate from your storage. And so with compute and storage decoupled, you can scale them independently and just particularly as you need. Now, it's just a compute engine, which makes it possible. And the other key advantage here is you get to bring your compute to where your data resides. And like I said, there's no disk storage in Spark. It's just an in-memory processing. And so you take your compute, you bring it to where your data already resides, in that S3 bucket, in that ADLS container. And this provides some advantages. You have increased data storage control. You can define the file types, the location, the redundancies and resiliencies, and all the different structures around your data. You've got a lot more control over that when you are just using file storage, like a data lake. And you can control, when the data stays put, the compute comes to it, you get control over that. And so that's a key advantage of the separation that we have. You also have reduced cost. So storage itself in a data lake is ridiculously cheap. It's very cheap, almost not something to think about when you're storing terabytes of data. It's just the cost is very inexpensive. The compute is the expensive part, but it allows you to decrease your storage costs a lot by keeping it in the lake and not having to make copies of it, because you're bringing compute to your data instead of moving your data somewhere else. And this is what leads to a speed to analytics. Overall, because you're not moving data as much, and because moving data is expensive and time consuming, loading it into different systems, loading it into different databases or data warehouses, if your data can stay in your lake and not move, that increases the speed you can bring analytics to market and analytics to your users. So that's framework number one. That's key that was introduced with Spark, is this separation of compute and storage. We no longer think about them as a monolith. We now have independent entities that we can scale appropriately, and we have some granular controls over both of them. And the second piece is the data lakehouse. Unless you've been under a rock for the last 5 years or never pay attention to the data world, I'm sure you've heard about the data lakehouse. It's everywhere. It's been about I forget when, so Databricks coined the term maybe 7 or 8 years ago, and they have great marketing, so it's really spread quickly. And we've covered the first part of a data lakehouse, and that's this flexible and scalable compute. This is key part number one of what makes a lakehouse possible. But the second piece of this puzzle is worth spending a little bit of time about, and that's an open table format. And so before we get to the open table format, a folder of files does not make a database, right? In a data lake. So until you had until recently, until these file formats came up, you just had things like CSVs and Parquet and Avro files, and didn't provide you the features that you're used to in a database. A lot of those core functions, ACID transactions, or the ability to merge and upsert, rollbacks and restores. They were just files. Like, it was just a CSV out there, or just a Parquet file out there, and you couldn't do any of the complex operations that we're accustomed to and that we need in a database. And so those things just didn't work in a traditional data lake. And so that's why a data lake used to always just be a staging ground, and then we would still load it into our DBMSs, our databases. Well, now we have the development of these open table formats. Delta, Putty, and Iceberg are the really big players here. Most popular being Delta, and that's the basket that Microsoft has thrown all of their eggs into, is the Delta format. But what these new formats give us is they allow us table-like properties. These are table-like files. They can operate and be managed like a database table can. So now things like atomic transactions, consistent reads and writes are possible on a data lake. You can do merges and updates, and inserts and deletes and manage those tables much more effectively. You got time travel with Delta, where you can look back at the history of how things are do restores to different points in time. So these are essentially allowing us now to have not just files in a data lake, but to have table-like entities in our data lake, which evolved to really make the data lakehouse possible. So that's got a second key part. So if you add scalable compute to an open table format, and you mix in some of your data warehouse modeling, you take these table-like files and you model them and design them like you would a data warehouse, or at least pretty similar. There's some things that aren't going to be exactly the same, but you would model it pretty similarly. That's when you get the data lakehouse. Got some flexible compute that's separate. You have an advent of a new table format that showed up in just recent years that now lets you do table-like actions on your files in your data lake. You can model it like a warehouse, and you now have a data lakehouse. This is where the data lakehouse comes from. And Spark is the really a foundational component of that. Data lakehouse doesn't exist without Spark. Let's look at the flavors of Spark now. So that's what Spark is. That's what you do with Spark. That's kind of how it fits into the data architecture and those key things about separating compute from storage and having data lakehouse. But now there's a few different flavors of Spark we got to dive into. And this is the fun stuff, I think. So you have the original open source project, Apache Spark. Great, great project. Everything is built on top of this open source project. That's flavor number one, and you're really your first option, the original option. Option number two is a managed version of Spark. So right now, one option of this is something like HD Insights in the Azure world. In the AWS world, it might be EMR. But you have a managed insight, and we'll talk more about what managed means. The third flavor might be a managed and optimized version of Spark. And this is where you get the Databricks versus Synapse Spark pools debate. Right now, they're going to go in the same bucket. We'll compare and contrast them a little bit more later. But right now, managed and optimize is how these are built. So these are just a managed version of the open source project. They also have optimizations and performance tuning built into them. And then the exciting new player on the field. And again, unless you've been living under a rock for the last 2 months, you've heard about Fabric. Microsoft put just a little bit of marketing effort behind Fabric. And now you have the first SaaS Spark available on the market. So a software as a solution or software as a service, Spark runtime. Open source, this is IaaS. You provide the infrastructure, not IaaS. You get just the software and you have to manage all the infrastructure. This is kind of an IaaS solution, maybe a light PaaS solution. This is the first SaaS solution that you have, but that removes most of the overhead of managing it. At least somebody out there, maybe, if you're familiar with Snowflake, might be asking, what about Snowpark? And so if you've dabbled in Snowflake or you have a Snowflake footprint at your company, Snowflake marketed Snowpark as a Spark alternative, and it's relatively new. But a few key things. Is this a flavor of Spark? Well, not technically. It's not Spark. It's got a very clever name, Snowpark. If nothing else, Snowflake has an amazing product. They have amazing marketing as well. So they have great ways of presenting their products. It's very Spark-like. It's not actually Spark. What it is, it's really a translation on top of their Snowflake SQL engine, which is a phenomenal SQL engine, but it's a proprietary engine. It's not based on the open source project of Spark. And so it's great if you've already got a Snowflake environment. It's a great extension of Snowflake to maybe provide some additional language support. So now you can do some ETL in Python or Java or Scala using Snowpark with your Snowflake warehouses. But there's also some limitations. It's nowhere near the same level of maturity that you find in the managed Spark runtimes like in Databricks or in Synapse or even in Fabric. There's a lot of some limitations. You don't have the same streaming support. You have limited to no library availability across these different languages and tools. And so it's a great extension of Snowflake SQL. If you want to have some more Python support or Java or Scala or things like that to do some ETL work, it's not a replacement for Spark. Spark is still, specifically probably these managed and optimized versions of Spark are still far ahead of what Snowpark offers. All right, so that's just a short sidebar. We're not here to talk about Snowflake. We're here to stay in the Azure stack. And so let's stick back there. Let's talk about the flavors now in detail. It's summer. Everybody loves ice cream. And so let's think about flavors of Spark being ice cream flavors. Let's say first, open source Spark is vanilla. It's the OG, classic, loved by all. Everybody loves vanilla ice cream. And so this is the open source project. And some great pros of the open source project. Got full Spark with all of the features of the open source project, no software cost, which makes it easy to quickly install on your machine. If you want to learn Spark on your own, you can go download it for free right now, run it on your machine, submit some jobs, figure out how Spark works, learn about the tool. So that's awesome. But for many reasons, most companies don't use straight up open source projects. It almost always they're using managed projects. An open source project it's like adopting a puppy. It's like that free puppy sign on the side of the road. It's like, hey, the puppy's free. But once you actually bring it into your home, you got to feed and the vet bills and all the work that comes along with it. There's a lot of feeding, caring that comes with an open source project. If any of y'all are running an open source project at your company, just straight vanilla, I'd love to hear about it because it's just kind of fun to hear about why you choose that because there's almost always a managed option as well. But you're kind of forced to build, manage, maintain environments, versions, and clusters all on your own. So that's the open source original project, and that's our vanilla flavored. Next, we have cookies and cream, or a managed Spark version, which has all the original vanilla plus chocolate chip cookies. Right? So who can really go wrong with that? Not chocolate chip cookies. I guess it's like Oreo cookies, chocolate cookies in there. And so this is like HD Insights, a managed version of Spark. Again, pros for this, it's full Spark, full open source features, managed clusters. So for much easier deployment and versioning and scaling, you get some good granular controls that are a little easier to manage than just the open source project is. We get VM types and serialization in your cluster managers can be handled quite well and easier here in a managed version. But you do have a lot more manual configuration required and a steeper learning curve than what's coming next. So this is a con for a lot of companies. They're not interested in managing some of those pieces, and the learning curve can be steep. And right, you do just get the vanilla Spark. And so no performance optimizations are built in. It's just a managed version. And this is, as I mentioned, AWS EMR fits in this bucket. So if you have an AWS instance, this is kind of what the parallel would look like. You don't have a friendly UI or a notebook environment like you do, again, with what's coming next. So there's our second flavor of Spark. Third flavor, I'm going to call a milkshake. This is Databricks and Synapse Spark, managed and optimized. All the great ice cream blended to perfection, plus whipped cream and a cherry on top. At least a small goal of this was to make you hungry by the end of it and to maybe go out and grab some summer ice cream in beautiful Michigan evening. Or maybe you can grab some right now while I'm talking. That would work too. So some pros about this, because this is the dominant player in the market, is somebody's almost always using one of these two pieces, one of these two tools. Very user-friendly, a much shorter learning curve than any of the previous options. You have a lot of those configuration controls are managed by the runtime. You don't have to think very much about versioning or cluster managers or serialization or any of those pieces. That gets taken by the runtime, and that's really what you're paying for. You get easier integration with these tools. These are PaaS platforms, and so the ADLS, Gen 2, dedicated pools, Git, all that good stuff. Great integration across those toolkits. Easier cluster management, things like autoscale and pause, cluster pools, even some serverless options. So you're really not thinking near as much about the size of the servers running the work, because a lot of that gets handled by the management of the runtime itself and by the tool. And you've got baked in performance optimization features. Both Databricks and Synapse have done a lot of work at investing in how do we performance tune our runtimes to go beyond what open source Spark does. And so there's a lot of that baked in, and so some optimization features that you have at your fingertips to improve over what's the original tune, your original project. Cons, if you have other ideas, great. At least one of the key cons is cost. This is just going to be a little more of an expensive option. You're getting a lot of benefits, but you're going to pay a little more. All right, and the third, let's see, this is the fourth flavor. We had vanilla, we had cookies and cream, we had milkshake. SaaS option, Fabric. This is the banana split, an indulgent, iconic ice cream experience. People love SaaS solutions. SaaS solutions have dominated the market over the last decade in all shapes and sizes in all different areas of the industry. And now it's really coming to the data tool and the technical data user in a lot more meaningful way. Snowflake did this with the data warehouse. It's a SaaS data warehouse, or a very SaaS-like data warehouse. Fabric is doing that with their data warehouse, but also now with a Spark runtime. And so some of the pros about this, plenty. The first SaaS experience, as we've talked about, very user-friendly, even easier than a Databricks or Synapse Spark runtime. Really great integration, not just with OneLake, ADLS, and Data Factory, but also with AWS and soon GCP. You can connect your Fabric Spark clusters directly to data in different clouds. Easy capacity management, like extremely easy. I barely thought about it at all. I was working on it earlier today. There's a capacity attached to my workspace in essentially what looks like Power BI, and then I just run things, run code. I don't have to manage my clusters at all. I really don't have to think about it. It's a very broad bucket of a capacity that I'm buying. And you get the similar, I think the same, I haven't tested this robustly, essentially the same performance optimizations that you get with Synapse Spark. Perhaps the cons, cost is still a bit of an unknown with Fabric. We know how much the different capacities will cost, but we aren't really to the point of comparing workloads and comparing production workloads. And so no one's running Fabric in production yet. It's still in public preview. And so we're not comparing workload to workloads extensively yet. We don't know how much a capacity at this size costs versus a clusters at this size. Cost an unknown. It's probably going to be a con for some people. And you have limited customization and config. This has been a pro in other places. Con here, maybe. There might be companies and industries where you're interested in getting under the surface a little bit more and playing around with the knobs and switches. So what exactly are the VMs we're running on? What are the things that I'm used to being able to configure with maybe some of the past solutions that you just don't have access to with SaaS? It's all managed for you, which is a pro for some. It's a con for others. Okay, and then here's a little bit of what was promised, a little bit of a comparison between these three. And so we're just going to walk down these one by one and see where we hit. This is where things get a little bit fuzzier and a little controversial, perhaps. From a performance perspective, your mileage is going to vary on this. Databricks is probably going to win just across the board. Databricks has the most advanced and mature Spark environment out there. Ahead of Synapse Spark, and then Fabric and Synapse Spark are essentially clones in this way. And so those are both the same. Solid performance, not the same level you get from Databricks. From a feature and config standpoint, and just feature maturity, Databricks is still going to win. It's been on the market longer. It's much more mature product. And so the richness of the features and your ability to granularly control VM types, as well as having like the different visibility into the runtime and what's happening, and the logging and monitoring and auditing, Databricks is going to be more advanced there, as well as streaming. Streaming is a big one for a lot of people that Databricks just tends to still be far superior over the Synapse runtimes. Azure integration, I'm going to put for sure Fabric and Synapse are just much tightly integrated. Databricks is close. It's very well integrated with Azure. It's not the same as a first-party product in that way. It is still a little bit clunky in terms of mounting storage. There's just some extra steps you take that you just don't have to do when you get to an Azure native or a Microsoft native product like Fabric or Synapse. From a compliance perspective, this can also be a barrier for at least some customers I've seen who they're not as interested in onboarding another vendor like Databricks. They want to just stay straight Azure. And so compliance can sometimes be a consideration where, hey, I'd rather just stay all Microsoft and not have to think about another vendor mixing into it. Cost, Synapse Spark is probably going to be cheaper. Again, I think mileage is going to vary. Some people are going to have different experiences here based on your workloads. Databricks is probably it's the premium option. It's the gold standard. It's going to cost a little more. And Fabric, as we kind of said, jury's still out. I don't know how Fabric's going to fall on this. I expect it'll be an expensive option, but the features and the flexibility it provides might be worth it. Ease of use, Synapse and Databricks, fairly similar. You have a very friendly UI. You have kind of easy management of stuff, but still not the same effect of what you're going to find with Fabric and the simplicity of running Spark in a SaaS environment. There we go. So there's kind of our breakdown of that. And this is where, as I said, this is my opinion, not Microsoft opinion. Should have clarified that at the beginning. It's just some ideas and kind of roughly my experience and things that I've heard. I'd love to hear different experiences if anybody has anything. So what would you choose? Databricks, Synapse, Fabric. Pick Databricks if you're already on Databricks. The biggest pain point is going to be if you're on Databricks and you try to move to something else, you're going to find that Synapse, Spark, or Fabric is just going to leave you lacking in many ways of what you were used to with Databricks. So if you need the latest version of Spark, then Databricks is going to have that first and foremost. They are the quickest to have that runtime available. If you need the most performance scalable, or most performance tuning and configuration options, that's in Databricks. And if you want the most feature mature for streaming and logging, etc., that's also Databricks. If you want or need the absolute best performance because you're streaming data at petabyte scale, just a few of us, or you just have really, really, really low latency requirements, then Databricks is probably your choice. It's just going to provide the most value if those are your core needs. Synapse. Pick Synapse Spark if you've already got a meaningful Synapse footprint. Dedicated pools or pipelines, and you're already in that world, then keeping the single pane of glass that Synapse provides is meaningful and useful, instead of jumping into another environment to do your Spark. If you're already in Synapse, stay in Synapse. You've got stringent compliance or protocols, security protocols. This could be a meaningful way just to stay in Synapse. Hey, don't go out to a third party if you don't have to. And if you're looking for maybe the most cost-effective solution, Synapse Spark might be a better option. Could be a good choice. Third one, pick Fabric. And we're learning about this right now still. Why would you pick Fabric? If you already have a Power BI premium capacity, then moving to Fabric is going to feel really familiar and really easy integration. Power BI premium capacities are essentially the same as a Fabric capacity. The user interface and the experience is almost the same. It's just going to make a lot of sense for you to step right into Fabric and use capacities for Spark in a very similar way. And if you're new to Spark and really just trying to just put together some quick use cases or build out some pipelines or ETL work using Spark, it's going to be a really easy onboarding experience. And if your users aren't real technical and they don't want to think about sizing clusters or managing any of the backend stuff, then great, Fabric's an awesome choice. And if you're already leveraging some of the other data components within Fabric, and as I said, no one's really doing this yet, but if you have plans to leverage the lakehouses, warehouses, direct lake experience, one lake in Fabric, then this is going to be an obvious choice. No one really makes these kind of choices in a vacuum. Like you already have something, like you already have Azure, or maybe you already have a little bit of Synapse, or you already had dabbled in Databricks, and so things are already kind of familiar over there. And so generally, there's already something that's going to nudge you one direction, which is why these first ones are already kind of if you're already on Databricks or if you're on a Power BI premium capacity, that can push you one direction and overrule a lot of these other considerations. But if you are starting greenfield, haven't explored Spark in any meaningful way, and then moving down these lower level decision points might be a lot more meaningful for you. All right, so I kind of rolled through that a little bit faster tonight. So we're at like 35 minutes, and so I'm just going to open up for Q&A. I don't know what y'all's level of experience with Spark is, how much you've seen it at your company, but happy to dialogue about any of these pieces now, if there's something else we could explore together or other things that came to mind.
Is Synapse Analytic Pools the exact same thing as serverless SQL pool, or different, or?
Yeah, so Synapse has dedicated pool, which is a data warehouse, and then serverless is doesn't have any data storage. It's just a flexible SQL engine
Yep.
Yeah, so serverless right now is usually what you would use if you just want a SQL endpoint to read files from your lake. So that can work well for that if you want an easier onboarding instead of Spark. Then people use serverless usually to move data around in their lake from different zones or things like that. And that's a nice on-demand SQL engine. You're not provisioning it, you're just paying per use. And so paying per query really, as opposed to a dedicated pool, which you're paying for every hour that you have it on.
So I know you mentioned, Apache Spark. You can download it, install it on your machine, and just play with it.
Yeah.
So I'm a old school SSIS guy.
Yep.
So just looking for ways to, just dabble my fingers in it. Most of what I have, worked with professionally has remained on-prem.
Yeah.
So not sure if you have any recommendations for, just to get started. Sounds like Spark with just some data files maybe is decent way. No, what do you think?
Yeah, so SSI, so maybe SSIS being kind of a, it's a GUI interface, or like you have kind of like objects that you're dragging in on a logical canvas.
Right.
The natural successor to that is usually like Data Factory, or
Right.
and that lives in Synapse as well as in Fabric as
Right.
well, and other data factories. So that's going to be one of the most natural transitions. What comes maybe once you acclimated to that is this thinking through like, what if I want like code-based elements as a part of my data pipeline? So I'm, maybe I'm loading some data, looking up some data, doing some logical work, and then I want to run some complex transformations. And that's when I call a Spark notebook. And I have Python code or even SQL code that runs all my complex transformations. And then I have another activity in my pipeline that loads data into a warehouse or loads it into their zone of the lake. So it's really like a piece of the puzzle, Spark, and then you would still use a tool like roughly like SSIS or like Data Factory to just orchestrate and logically arrange how those are going to fit.
Okay. Cool.
I didn't mention this, but if you have access to like a Power BI environment, like you can get Fabric for 60 days right now. If you want to go in and play with these Fabric environments, you get 60 days of a capacity. So you could go try out notebooks and just play around with the environment there. There's some tutorials on Microsoft. Microsoft Learning Paths that can be pretty easy to experience for free and easy now.
Nice. Very cool. Any other questions?
When you integrate all these products together, what will be the mostly language used? Like, I don't know, C#, scripting, Java?
By far, I think the most popular language for Spark is Python. That's what Databricks tends to push. It used to be a lot of Scala and or Java. I mean, those are very similar, and people would write Java stuff. But more and more Python's been the dominant version, or the dominant language being used in any Spark runtimes, and SQL. I mean, there's still tons of just like database people who are jumping in, and so many more people know SQL, and so people do a lot of Spark and Spark SQL. It's not quite T-SQL, very similar. There's a few different dialect differences. People do a lot of SQL and then a lot of Python right now.
Anything else? Go ahead.
Oh, I was gonna say, like, there's at least some people who are really interested in doing specific machine learning things in there, and that's where the data scientists always have their preferred thing. So it's like R or Python, and that they tend to fight over which one's better. But for specific use cases, you might land in a specific language. General use cases, it's Python and SQL. Almost probably 90% of the time, new builds are going to be Python and SQL.
So I work with a lot of data science guys, and I know back in the early days, there's a lot of SAS, like SAS, the company for the statistics, and they have, seems like there's, over the last, I don't even want to, speculate what the percentage of people are that had been in SaaS, they're now using R almost exclusively just because SaaS was expensive, R's free and pretty powerful. You know, and of course SaaS being a proprietary, you know, thing. Can't imagine there's a whole lot of integration between like that and like these products.
Yeah, I haven't worked with SaaS much before, so I'm not sure even what that looks like. Or I think I've heard of some projects kind of helping people migrate off SaaS and like doing SaaS code translations. But I haven't seen how they might integrate or what that might look like.
Yeah, and plus, I mean, pretty much anytime we were getting people in, it's like, you know, we do a lot of college grad hires, and it's like you were teaching them all the SaaS stuff. And but then it's like then when R started to come along, it's like, well, they were coming out of college with our, you know, experience. So
yeah.
And we were already moving that way anyway. So can't imagine. I don't know why you'd want to go that way anyways. You can do it all in R anyways. Cool. Well, if there's nothing else, go ahead.
Michael, what are the use cases you guys are using R for? Or like, what are those data science types use cases?
So I work for a P&C insurance company, so property casualty.
Yeah.
And I work in the actuarial division. And basically we have a predictive analytics team, well, multiple teams now. So a lot of you know, predictive modeling, generalized linear modeling, you know, just a lot of you got, you know, oh God, I don't even know what all they're doing now. You know,
like the
conversion
rates,
insurance.
Yeah.
Yeah. You know, conversion rates of quotes, you know, what's getting converted from a quote to an actual policy. And, you know, it's actuarial kind of seems to be the R&D of like insurance almost, just because it's like, you know, they're the ones going, well, what if we did this or what if we did that, and run the numbers and stuff. So, you know, it's and we like seeing all the company's data as much as we can get, as often as we can get, as far back as it goes. So yeah. Well, this was good. So I know the fabric stuff's pretty new. Maybe we'll talk towards the fall, see if you want to do Prezzo on that stuff.
Yeah, I might have some more learnings by then. I've been playing around with it. Certain things just still don't work yet. So like I was messing with something today and I'm like, this says it works on the documentation, but I can't get it to work. So yeah, a lot of bugs still. Maybe by mid-fall they're targeting in mid-fall. So by then we might have more stuff.
Cool. All right, well, I'm going to go ahead and stop the recording now. And I will get this out on our YouTube and I'll share it to everybody. So, okay, hitting stop.